Okay, today we'll be working on problem 19 from the homework due on the 27th. Okay, so we have, this problem says there's a 5 kilogram object attached to the end of a horizontal spring, negligible mass, and a constant of 350 newton meters. Okay, so we have a wall and a spring. Right, with a 5 kilogram mass. All right, and the mass is compressed, so the spring is. Here's equilibrium, right? Equilibrium, and this is 10 centimeters here. Okay? All right? And we have to find the final speed of the block when it is 8 centimeters from equilibrium. So we want to find its speed when it's here, okay, at 8. Okay, so spring is a conservative force. So we have E mechanical initial is equal to E mechanical final, meaning that our work due to the spring plus the kinetic energy is equal to the work done to the spring final plus the final kinetic energy. So it starts at rest at 10 centimeters. Okay, so 1/2 mv initial squared plus the spring. So this is kinetic energy initial plus the spring, which is (1/2 k x initial squared), and this is all equal to 1/2 mv final squared plus 1/2 k x final squared. Okay, so the initial velocity is 0, right? So this goes away, 0, right? This, we have our k value of 350 newton meters. Newtons per meter, right? So we can plug that in. Let's convert centimeters to meters. So this is actually equal 0.1 meters, and this is 0.08 meters. Okay? So then we can just plug in numbers. Well, first let's solve for V final. Okay? So we can bring over is 1/2 kx final squared to the other side of the equation and solve for v. So we can get v final squared is equal to 2 times the quantity of 1/2 kx initial squared, right, minus 1/2 mv final squared, all divided by m, right? So that cancels that, okay? So then we can say I made a mistake somewhere. I apologize. Action. Okay. Meaning we can solve for v final in this situation. V final is just 0.502. Does that make sense? Any questions? Nope. No one's even watching. Cool. Here, let's do one more problem. Since there are no questions. Oh, this has multiple parts. Okay. What is the speed when the object is 5 centimeters away? Okay, so in that situation, you keep this at 10, or 0.1, and you make this 0.05. Okay, meaning this whole thing here goes up, so the V final will go up. You get a value of 0.837. Okay? I'm sorry, this is wrong. $7.25. Okay. Now, that was for when this was when it was 5 centimeters. Okay. Now, if we want to do the final part as for when it's at equilibrium, so this actually here goes to 0, right? So this whole term can go away, and the final velocity is equal to the square root of k over m times 0.1 centimeters squared, 0.1 meters squared, right? So when this is 0, this value here is 0.837. Okay? Does that make sense? Great. Let's move on. Uh-oh. You threatening me? Come on, man. I thought this was a professional environment. Okay, an ice cube slide. We're doing problem 35, by the way. Same homework assignment. So in this problem, it says an ice cube slides down without friction at track shown below. Calculate the speed at points B, C, D, and E. Okay. So we have our track comes down, and then it goes up, and it comes back down. Okay. And here's the ground. We can say this is YA here. This is YB, a little lower. Here's YC, right? Here's YD. Okay, and here's YE. Okay. So this YA is equal to 5.5. Okay. It's 5.5. YB is equal to 3.3. This is 2.2. YD is 3.3. And YE is 4.4. Okay. So now we have to calculate the velocities. All right, so we just use conservation of energy and momentum. So we're going to say VA, so it starts out at rest, so VA is 0 meters per second, right? So then for part A, when we ask for part B, we use mgya plus 0, this is KE here, and 0 because it starts out not moving, equals mgyb plus 1/2 mvb squared, okay? And we can solve for VB equals, cancel out all the mass, right? Equals square root of 2 times GYA minus GYB. Right? So this ends up being 6.6. Okay? Now, for the next part, it asks for the velocity of C. So literally all we have to change is our values, right? Right, so this can be changed to C. Let's use green so you can see C. And then this turns into 8 meters per second, which makes sense. It gets faster as it gets lower down. Okay, now we just keep doing the same thing for the next parts of the problem, right? So we just change what we want to find. It says conservation of energy. The same energy goes in as comes out, no matter the height, right? So now we can say GYD right? And then we just plug in values of D. I forgot to put a parenthesis. All right. This is D. Value of D, 6.6. All right. Now the last one is E, and we do the same thing we just did for the last 3 parts. Like almost exactly the same thing, except we use different variables. Good times. So we literally just change all these D's to E's. E, 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 E. You plug in the new values in your calculator, and you get a value of 4.6 meters per second, which makes sense because as it goes back up, here's 0. In reality, this is higher than this point. This is higher than this point here. I apologize for my poor art skills. That's just how it goes. All right, thank you for watching. I hope you enjoyed it.